Okay, so this is just a quick video for Pre-Lab 8, the last question, question number 7. There's a lot of words here, and really the main point here is that we're going to start talking about this unit that's called a mole. And in class I told you that that's really just a counter, just like a dozen means 12. A mole means 6.022 times 10 to the 23rd. It's a huge, huge number, okay? And so here it says, therefore a mole of iron has this number, 6.022 times 10 to the 23rd iron atoms in it. 2 moles of water consists of this number of molecules of water. So basically I'm taking this number and I'm multiplying it by 2. That's going to lead me to this bigger number here, right? 1 mole of 0.1 mole of marshmallows consists of this number of marshmallows. So it's just a counter for, that number. Okay. So here in part B, it says if 0.2 moles of nickel reacts, determine the number of moles of each of the other reactants and products that must be involved in the reaction. So if we go down here, here is my table, my reaction table, and it says nickel plus HCl goes to H2 plus nickel chloride. And here I've got some information about the number of moles of nickel, the molar mass, and the grams of total nickel that I'm using. So if we were to use 0.2 moles of nickel, this is the molar mass, so what this tells me is that for every mole of nickel, it weighs 58.69 grams per mole, okay? So, in order to get to this bottom number, 11.74, really all I'm doing is I'm saying 0.2 times 58.69 equals 11.74, right? So the 0.2, that's the number of moles, 58.69, that's the grams per mole. So if you look on your periodic table under nickel, Ni, you'll see 58.69. So if I multiply those numbers together, the units of moles will cancel and I'll be left with 11.74 grams of nickel. Okay, so that's sort of saying this number of moles of nickel weighs this much. So the first thing that we need to do is, now that we've sort of established that, is balance this chemical equation. So this chemical equation is not balanced yet, but all I need to do to balance it is put a 2 here for my HCl, and these will all be 1s. And in this case, since there's space there, I'm going to fill in those numbers there. So what this tells me is that for every 1 nickel atom, I'm going to need 2 HCl molecules to react to give me 1 H2 molecule and 1 nickel chloride molecule as well. So this is my ratio. And now I need to figure out, okay, based off of these ratios, how many moles of HCl will I need to completely react with this number of moles of nickel? So if another way to say that is I have 1 mole or 1 molecule of nickel, how many HCl's will I need? Well, I'll need 2. So if I have 0.2 moles of nickel, how many moles of HCl will I need? Well, I'll just need 0.40. I will need twice as much, right? So it's a 1 to 2 ratio. This will be a 1 to 2 ratio as well. 0.2 to 0.4, that's going to give me my number of moles of HCl that I will need to completely react. For the molar mass, I'm going to look up on my periodic table and I'm going to say hydrogen weighs 1.01, right? H weighs 1.01, and Cl weighs 35.45. So if I add those together, the molecular mass for HCl is going to be 36.46 grams per mole. And then for my grams down here, right, that's asking you for 0.4 moles, how much does that weigh? So again, I'm going to do 0.4 times 36.46, so that's 14.58. So what that says is if I take 11.74 grams of nickel and I react that with 14.58 grams of HCl, that will be a perfect ratio, a 1 to 2 ratio, to use up completely all of this nickel and all of this HCl. So I'll leave the rest of this table for you guys to work on and figure out, but that should give you an idea of sort of what's going on in this table and how we're going to use that as we move forward in this lab.